For the function y equal x cubed minus x squared, let the number of intervals be n instead of a specific number, and let the interval be from a to b. Then we get the area to be the summation as shown. When you put this in your calculator, make sure to leave out the b minus a over n outside of the summation formula. So close the summation formula before you put the b minus a over n, or else your calculator will be bogged down in trying to calculate the summation. So leave this outside of the summation. After you put this in the calculator, use expand on the calculator, which is under your algebra key, which is F2, to expand the above summation and write down your answer. When you write down your answer, you're going to get a to the fourth over 2n minus a to the fourth over 4n squared minus a to the fourth over 4 minus a cubed b over 2n plus a cubed b over 2n squared minus a cubed over 2n plus a cubed over 6n squared plus a cubed over 3 plus a squared b over 2n minus a squared b over 2n squared minus a b cubed over 2n minus ab over 2n plus ab squared over 2n squared plus b to the fourth over 2n plus b to the fourth over 4n squared plus b to the fourth over 4 minus b cubed over 2n minus b cubed over 6n squared minus b cubed over 3. Now remember, we want to take the number of intervals to approach infinity. So take the limit as n goes to infinity for this expression. Now make sure that you take the limit as n goes to infinity of the expanded expression. If you try to take the limit as n goes to infinity of the summation, your calculator will be overloaded and then it will not simplify out. It will just keep working and never give you an answer. So make sure that you expand the expression out first, then take the limit as n goes to infinity. Now as n goes to infinity, you should notice that every term that has an n in the denominator will go to 0. After you simplify this, you get minus a to the fourth over 4 plus a cubed over 3 plus b to the fourth over 4 minus b cubed over 3. Simplifying this, I'm going to change it to b to the fourth over 4 minus b cubed over 3 minus a to the fourth over 4 minus a cubed over 3. And this is what the summation should simplify into. Now let's try y equal m times x. Now writing the summation out, we're going to take the summation from I equal 1 to n substituting a plus b minus a over n times I into our function. We'll have that a plus b minus a over n times I multiplied by m. I is going to go from 1 to n, and then we'll multiply that summation by the width of each rectangle, which is b minus a over n. Again, I'm making sure that I keep this width, b minus a over n, outside of the summation formula so my calculator doesn't bog down. Using my calculator to expand this out, which would be F2 algebra, expand that expression out, I will get a squared m over 2n minus a squared m over 2 minus abm over n plus b squared m over 2n plus b squared m over 2. If I take the limit of this as n goes to infinity, each term that has an n in the denominator will go to 0, and this will eventually give me b squared m over 2 minus a squared m over 2. Continuing the process for the next function, y equal x squared. Erase these guys. We're going to have the summation formula from I equal 1 to n. Our intervals from a to b, so we're going to start at a, and we're going to add a width, or multiples of our width, b minus a over n times I. Substituting that into our function, so it's going to be our a plus b minus a over n times I, quantity squared. I is going to go from 1 to infinity, or to n. And then multiply by the width of each rectangle, which is b minus a over n. Make sure again that this is left outside of the summation formula. We don't want our calculator to be overloaded. When we expand this out, we're going to get a cubed over 2n minus a cubed over 6n squared minus a cubed over 3 minus a squared b over 2n plus a squared b over 2n squared minus ab squared over 2n minus ab squared over 2n squared plus b cubed over 2n plus b cubed over 6n squared plus b cubed over 3. Taking the limit of this expanded form as n goes to infinity, each term that has an n in it will go to 0, leaving us with b cubed over 3 minus a cubed over 3. Now do the next two problems, problem 3 and problem 4, and hopefully you'll notice a pattern.